Now we've got the materials built into our scene. Let us work on the displacement shaders. To continue from this point, you can open the file called scene5.hip. So let me begin with the displacement shader of my cylindrical light top. Let me go inside its shop network, then inside the cylindrical light material top. And in here, to create a displacement shader, let me just maximize my network editor. I will hit Tab, and under Matter Displacement, I'll create a VFX displacement shop. This is the shop where you can build your custom displacement shaders. Let me go inside. The displacement for my cylindrical light top will be the mix of two nodes, a burlap node, which gives some clothy look, and a noise node. So let me begin by creating the burlap. I will just hit Tab, and I will type burlap, and then I will hit P to show the parameters of this node. And for this node, the only thing I want to change is this frequency here. I want to make it 100 instead of 50. Then I want to have control over the amount of the burlap, so I will just multiply it with a constant. I will hit Tab, I'll create a multiply node. I will just take the amount output of my burlap to the input 1 of my multiply, and then I will middle click on the input 2 and I'll create a constant node. I will then select this constant and I will make its float default value 0.1. Now let us create the noise part. First, let me create an anti-alias noise. I'll go here, I'll hit Tab, and I'll write the word anti, and I'll create this anti-alias noise node. Here, I will change its signature from 3D input 1D noise to 1D input 1D noise. Then I will make its 1D frequency 50 instead of 1, and its amplitude 0.25. Now, I want to drive this noise with the V coordinates of my UVs. So let me create a UV coords node. I'll hit Tab, type UV, and create this UV coords node. The UV coords are generally being read in from the UV point attribute on geometry. So those are the UVs you create yourself. While the SNT on the global VOP, you can see here this SNT, are the parametric coordinates that exist per primitive, which for polygons, for example, is a 0,1 coordinate per polygon, which is usually not so useful. But for patch surfaces like NURBS, this is a coordinate space that spans over the entire surface. So since I have a polygon surface and I created the UVs myself, I will use this UV coords node here. So as I said, I want to drive this noise with the V coordinates of my UVs, so I will take this T and I will just make it the input of the position of my anti-alias noise. Then for this noise, I want it to be more pronounced on the top of my cylindrical light and less pronounced near the bottom. So let me do that with the help of a ramp. I'll just zoom out, then I'll create a ramp. I will make this ramp a float ramp. Then let me drive it with my T attribute, which, as I said, goes from bottom to top on my cylindrical light top. And let me multiply it with the output of my noise node. So let me hit Tab, multiply, and I will multiply the two together. Great. Now we have the two lines. I will mix them together with an add node. I'll create this add node, and I will add my first line to my second line. Then here comes an important part where we will use what we've done so far to drive the displacements. So what I will do is I will hit Tab and I will type the word displace. And then I will create this displace along normal node. This is the node responsible of transforming any values I feed in the displacements. So let me give it the output of this add node. I'll take the sum and I'll make it the input of this amount attribute here. And then let me take this output node and connect my disp P to its P input and my disp N to its N input. One last thing before leaving this network, I want to have control over the overall scale of my displacement from the outside. So let me make the scale attribute a parameter. Let me go to my displacement node here and I'll middle click on the scale and I'll create a parameter node. I will just call it displacement scale, and I will do the same for the parameter label. Then let me delete this global node I didn't use and go up, and here I will connect this displace node to my sub output. Then I will go up again and I will right click and promote material parameters. And now you can see I have the surface parameters appeared here, which contain only the diffuse color, and I have a second tab here that appeared, that is the displacement tab, and inside it you can see the displacement scale and the ramp we have created to drive the noise from top to bottom. So let me make the displacement scale 0.13, and for the ramp, as I said, on the bottom I want the noise to be less pronounced, so let me just make the curve look something like that. That would do it for the moment. I will make this a small ROM interpolation, this also, and this one also. Now I want to explain to you another very important notion about displacements and about shaders in general. Let me go inside here, and here I will create a properties node. So let me hit tab and type the word properties. This properties node can be very useful because using it you can specify many attributes and properties to your material. Let me in particular use it to specify some displacement properties, for example. So let me right click on it and open the edit parameter interface. Inside here I will go to the for rendering tab, and in the filter I will type displacement. Then I will go to Mantra 10, and under shading I will add this displacement bound attribute. I will install it, and I will install this true displacements attribute. I will hit accept, and now you can see they appeared here in the properties of this node. So let me connect this properties node to my sub output, then go up one level and promote material parameters. And now you can see this properties tab appeared here, and inside it you can see those two parameters, displacement bound and true displacement, I had just added. Mantra displacements are both detailed and fast, though you have to be aware of displacement bound. Displacement bound determines a bounding box around the object, and that determines when the object is loaded by Mantra during rendering. If your displacement bound parameter is very small, you will get weird results, such as your displacements being clipped, for example, whenever the displacement pushes your object outside this bounding box. To solve such an issue, increase the bounding box by increasing the displacement bound accordingly. Of course, the correct setting will depend from case to case, especially of the size of your object in world space. But a good value to start with would be the farthest distance your object may be displaced, which in my case would be 0.13. So I will just input here 0.13. Keep in mind that the bigger the displacement bound, the more memory will be consumed by Mantra. So try to use the lowest possible value that gives you acceptable results. Now what about this true displacements checkbox? Well, as its name implies, turning it off will give you bump mapping, and turning it on will give you true displacements. So I will leave it as on for the moment. And now I'm done with the displacement of my cylindrical light top. Let me show you one more thing before moving to the displacement of the square light top. I will just minimize my network editor, and here I will click on this plus button, and under new pane tab type I will load the shader view. Let me just go to my network editor and hit P again. I'll hit L. I'll go inside here, and you can use in fact this shader view to have a visual feedback or real-time visual feedback of the changes you are doing to your shaders. So for example, if I go inside my VOP surface here, you can see that now I have a black color. In fact, because this is the translucent material we had done, I'll hit up again, I'll go inside my VOP displays, and here you can see the result of my displacement shader here directly in the shader view. So this could be very helpful when you are building shaders to have a real-time visual feedback for what you are doing in your network editor. Now let us do displacements for the square light top. Let me go back to my scene view, then to my obj context, and I'll go inside my square light. Here I will go inside the square light material and inside the square light material top. As I did before, here I will create a VOP Vex displacement chop. I will connect it to my sub output, and I will dive inside. Then here the main component will be a burlap pattern. So let me create a burlap pattern. Then I'll hit P, and I'll change its frequency to 300 and its roughness to 0.1. I do not need this global node, so let me delete it. Then let me create a UV coords node, UV coords. Then I will connect its S output to the S input of my burlap and the T to the T. Now as I did for the cylindrical light, I want this burlap to be stronger on the top and weaker on the bottom. So let me multiply it with a ramp. I'll create a multiply node. Then I'll create a ramp. Then I will multiply the two together. And I will drive my ramp with the T output of my UV coords. I also want to give a scaling parameter to the output of this multiply node, so let me create a constant. I'll just middle click here and I'll create a constant node, and I will make its default value 0.008.